All right, so the question is, what does the terms implicit and explicit parameter mean? What do those terms mean, explicit and implicit parameter? And that's in chapter 5, right? So they're talking about classes. So in that section that I just looked at, there's a class called product. And in this class, there's a function, is better than, and that returns a bool. I don't remember how they do it like this, but I think they even call it const, right? Like that. Is that right? Yeah. So this is, and I think they do this as well. They call it other. Product B. And actually, let me do the declaration here. So we have a class, and maybe we have something like this. Maybe there's a main function. I'm just going to rough this out. It's not precise. And so what we have is two functions. So we're going to create. We'll have a product. A product A, say. Let's not call it A. Let's call it product X. And I'm going to pass in some kind of a value there. And then we'll create a product a Y. And then we'll pass in another value here. And let's suppose those numbers that we pass into the constructor represent the value of the product. And then we can do something like this. We do if x dot is better than y, then we'll print x is better than y. Let's suppose that's what we want to do. We have two products, and we call one an X, we call one a Y, and those names are arbitrary. And there's some data that we pass into those product instances that represent some kind of a value. And then we want to know at some point in the code. Remember, this is a very simple little program, but there's lots of other potential logic involved and all kinds of stuff in there. But we're just looking at the kind of a narrow view of this, a simplified view. And so we want to know, somewhere in the code, we want to know if x is better than y. And if it is, then we're going to print something. And so we use this is better than function that's in the product class. And so it would look, now this, look at this. Here we have these constructors. The constructor takes some kind of a value. And so maybe we'll have something like a public section in here, right? And we'll have a constructor. Let's suppose the value is an integer. Here's the constructor right there. And we have an is better than function, and we have a constructor. So we could implement those in this declaration section. Well, let's not do that. Let's implement them down here, which would be more typical. Oops. So let's first define the constructor. And the constructor takes a value. which is of type int. And so we need to store that value somewhere. So typically we would hide it away inside the class in the private section. So we're just going to do something like this. We're going to do int, say, v. And so when we create an instance of product, we just take the v and we set it to this value that gets passed in. Actually, I don't like these names, so normally I would do it like this. Does the book talk about the this keyword in the chapter 5? Does anybody know? It's not mentioned in chapter 5, right? Well, it'll come up later. Let's leave that out so no one is familiar with it. See, here there's the value that's inside of the class. It's called a member variable. And this variable here, this has got the same name, but it doesn't represent the member variable. It represents a parameter to a function. And when this constructor function runs, we pass in some kind of an integer. And we can call it anything. So we call it v if we like. But the idea is it's meant to be set into this value field. But it's convenient when we do this. Now here we have, and we could even call this v value. Actually, this will compile. We don't have to. This name is arbitrary. In fact, we could omit this. We could declare the class like that. And this builds, this compiles. See, the compiler needs to know what is the data type that gets passed into the function. Here, we need to provide the compiler with more information. We have to give a name to the incoming data. We call it v. And then what do we do with the incoming data? Well, we copy it into a member variable called value. That's how that works. So down here, in this expression right here, we're invoking the constructor, the product constructor. So that means this code runs at this point here. In fact, we run that code twice. Remember, the purpose of this constructor is to create an instance of some data type, or an instance of a class. A class is a data type. Another example of a data type is int. Right? That's another int. So data types that's the type of some data. You can have a double, a float, a bool, a string, an int, a point. So here we have a product. And we create an instance of product and we call it x. We create another instance of product, we call it y. And when we create those instances, we pass in an integer. That's all we need to know at this point. Well, we need to know a little more here. We need to know, well, okay, you're going to pass in an integer. Here's the compiler talking to us. You're going to pass in an integer to me, but hey, you got to give it a name because you need it down here to do something with that value. So we're going to name it. Here the compiler doesn't need to know the name of that integer yet, just needs to know that it's an integer. So now the thing that gets passed into this constructor for product is just going to be copied into this value field. So it's convenient to do this. Like the values, it's going to come in as a value. I'm just going to put it in my value field. But then there's an ambiguity because when the compiler looks at value equals value, it doesn't know which value. You're just copying the local, argument value into itself. We don't want that. We want the integer that's being passed in, we want it to be copied into this field that's called value. It's in the class. So the way we do that, well, one way to do that is to give them different names. That way that's clear. But if we want to give them the same name, then we can distinguish between the two variables using this dash greater than, which is like, it looks like an arrow. And this is very common. You'll see this a lot. And you see this in other languages too. It's not just C++. Right? You see this in many other languages. Python. See this in Python. They don't use this. They use self. Okay, so if this is not in Chapter 5, then it's probably in Chapter 7, I think. It talks about pointers. Because this is a pointer to an instance of the class. So when this code runs here, this refers to the instance of the class. So we want the value variable that's associated with the instance of this product class, not the value variable that's being passed into the function. And one of the reasons I'm talking about this is because this represents the implicit parameter, and I'm just giving it to you from a different angle. So I'm going to talk about it a little bit differently. So, so perhaps just if that's confusing to you, well, let's just do this. Just want to make sure the names are different now. We need to let the compiler know, which integer is which. So the integer that's being passed in to the function is copied into the member variable integer. So just make sure they have different names. So now we have these two things. So when we call this function down here, x is better than y. Now if you think about that, when this thing runs, this is a function call. So we do x dot is better than y. When that thing runs, it's going to, you can think of it like this, that what I have highlighted there is removed and replaced with either true or false. So we say it evaluates to true or false. The expression that I have highlighted evaluates to true or false. If it evaluates to true, then we will print x is better than y. If that expression evaluates to false, we will not print that expression, that sentence. So this is a function. Remember, we've looked at functions before. Functions return things. Is better than returns a bool. Bool is a data type, like an integer or a double. But bool is a data item. It's a data type that has only two states. It's either true or it's false. You can't set a bool to anything other than true or false. If you have an integer n, you declare integer n, you can set it to a 1, you can set it to a -3, right? But you cannot set it to a 2.9. The 2.9 is not an integer. So the integer variable cannot take certain numbers. If you declare a double, if you go double x, well, you can set 2.9 to x now. Or you can set -3 to x in that case. So you've got these different data types. They have different possible states. The bool has two possible states, true or false. There we go. So I'm kind of getting off a tangent there. I'm covering a lot. So this function returns a bool, and it takes a single argument, which is a reference to product. And we'll talk about what this const means in a moment. And this const as well. It does not need that there. You can ignore those for now. And so the function, here's where the function runs, right there. We need to implement it. So is better than y. So we are an object. When this is better than y runs, we have access to our variables. So value is one of the variables that we have. So we can reference this value. We can operate on it. We can do this. We can output it. So when is better than runs, it's running. When it runs relative to an instance. You see this x dot is better than y? So here we're executing the function is better than against x, the instance x. And x is the one that has value set to 3. So here we're going to print, if we implement is better than like this, we will print 3. We're not going to print 2 because we're calling is better than on x. We're not calling it on y. Even though we're passing y in, we're passing y in as an argument. Oh, how are we going to print the value of the product being passed in? We would do it like this. We take product B and we want its value. Can you see that's a dot there? I don't know, I can't see that on my own computer, but that's a dot right there. So this function is better than when it's running. I'm going to show it down here. There it is, right there on the bottom. X dot is better than. So when inside the function implementation, value is the value that's a part of the x, and product B dot value, that's the value that's inside y. It's like y is being passed in as an argument. That means product B refers to y. So you were calling is better than with y. That means this, you have to do a little translation here. Oh, you called me y there, and now you're calling me product B here. It's like having a friend, and you call your friend, Fred, and you go into his home, and his parents are calling him Skippy. He's got 2 different names. So you got to keep track of the names and what they represent, right? So here, product B refers to y when this runs in this case here. See, you can think of, if you look at this function, the book says, well, you can think of value as being called through an implicit parameter, like that. You're saying, well, the implicit parameter is the object on which the function, or through which, the object on which the function is being called or executed. So that's what the book means by implicit parameter. And as I showed you, this is not actually valid, syntax. You don't say implicit parameter, but you could do this. This is good. That's a valid syntax. And that's redundant. We don't need to do this dot value. We can just use value. Because there's no other variable called value, so we don't need to distinguish between one value and another. They're all the same thing. But that's different up here. If we had called this value, we would need to use this down here. So this implicit parameter is the author's trying to get you ready for another concept, which is like this, but also just to understand how the function runs relative to an instance of a class, even though another class is being passed into that function as a parameter. Any other questions about it? I know this is hard to get, and it's hard to explain, actually. So Make a little more sense? Did it make a lot more sense? Maybe not a lot. Any questions on this? As we go along, maybe this will settle in more. As you read more and work through the code, it starts to become more second nature. In fact, is better than, let's suppose we, just to take this a little farther, we don't have to implement is better than as a member function. Oh, by the way, I forgot to do this. I needed to have done this, right? So you have to, the member function, when you go to implement the function, you have to say, hey, compiler, this function is the function for the product class. But let's suppose we don't make it. Let's suppose we make it what's called a global function or an ordinary function, a function that's not inside a class. It's just a function, which you can do in C++. You can't do that in Java. You can't do that in C#. But you can do it in C++. You can do it in Python. So some languages allow it, some don't. In this language we can do it. We have a function. Now, is better than, this doesn't make sense anymore. Do you see that? So this is no longer, we have a class called product, but the product class does not have an is better than function, say, right, as an example. Now this doesn't make sense because value is undefined. What's value? We're not inside of a class anymore. There's no set of member variables that we can access. So value is not there. So we have to get it from somewhere. So what we need to do, we'd have to rewrite this function to look something like this. Oh, we want is product A better than product B? So this is no longer good. So we can't use an implicit parameter. We have to use only explicit parameters. We can only use data that's passed in directly or indirectly through the arguments of the function. So here all parameters are explicit. There is no implicit parameter because we're not inside of a class. Of course, we wouldn't call it like this either. This does not work. This will not work. We'd have to call it like this. If is better than x comma y. That's the other way to do the function. See, now x is no longer an implicit parameter. It's now an explicit parameter. Does that help even more? Trying to really nail it in here. Okay. All right, that's that.